Hi there. I'm Koro-sensei. I'm going to be your chemistry teacher for today. Isn't that exciting? I will indeed destroy the Earth, but first, I'll be your teacher. Our first topic is how to solve for molecular mass. So let's start with the basics. What is the mass of sulfur? If you look at the periodic table, you'll see two numbers. 16 the atomic number and 32.07 the atomic mass. So let's say we're going to find the molecular mass of atomic fluorine. Fluorine has an atomic number of 9 and has an atomic mass of 19. So 19 is the molar mass of fluorine. The molar mass is equal to the atomic mass of an element. Let's try CO2 as an example. CO2 or carbon dioxide contains 1 carbon and 2 oxygen atoms. We'll just add their molar mass. The molar mass of carbon is 12.01 while the oxygen has a molar mass of 16. Since oxygen contains 2 atoms, you will multiply its molar mass by 2 and then add them up together. So it's going to be 12.01 plus 32. The answer is 44.01. And that is the molecular mass of carbon dioxide. Now let's work on another one that has more elements. C6H12O6 or glucose. So we have 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Each carbon atom has an atomic mass of 12.01 and each hydrogen atom, if you look at the periodic table, it's 1.008, and each oxygen is 16. Now, we'll multiply 12.01 by 6. 1.008 by 12. And 16 by 6. So, 12.01 times 6 is 72.01. 1.008 times 12 is 12.096. Then 16 times 6 is 96. Now let's add them all up together. And the answer is 180.156. That is the molecular mass of glucose. Next we'll talk about how to calculate the percentage composition of an element. Let's go over the formula. The formula is: the percentage composition is equal to mass of an element divided by the total mass, then times 100%. Now, let's try the example C12H22O11 or sucrose. The first thing I recommend doing is finding the molar mass of the entire compound, which I already taught you in the first topic. Feel free to rewind and to review. And if you want to try solving the molecular mass of the compound sucrose, just pause the video. So the molar mass of carbon times 12, hydrogen's molar mass times 22 and oxygen's molar mass times 11. So it's going to be 12.01 times 12, 1.008 times 22 and 16 times 11. And that equals to 342.296. That is the molar mass of the compound sucrose. Now, if you want to find the percent by carbon, you need to take the molar mass of all 12 carbon atoms and divide it by the total mass of the compound, which is 342.296. Then multiply by 100. So that's going to be 12 times the molar mass of carbon, which is 12.01. Divided by 342.296, then multiply by 100. And that gives us 42.1%. Now, let's do the same thing in hydrogen. Let's take the mass of hydrogen, which is 1.008, and multiply it by 22, because there is 22 hydrogen atoms in sucrose. And divide by 342.296. And then multiply it by 100. And that gives us 6.5%. And in sucrose, there are 11 atoms of oxygen, so we'll multiply the molar mass of oxygen, which is 16 by 11. Then, divided by 342.296 times 100, and you should get 51.4%. So that's the percent by mass of oxygen. Now, if you add 42.1%, 6.5%, and 51.4% altogether, this will give you a 100%. The last topic is I'll be showing you how to find the empirical and molecular formula. Here is an example. A compound is composed of 52.14% carbon, 13.13% hydrogen, and 34.73% oxygen by mass. What is the empirical formula? In this problem, we are given the percent composition of carbon, hydrogen, and oxygen. Basically, when you are given the percent composition, simply make it grams. Now, the next step is you need to convert the grams into moles. So, in carbon, the atomic mass of carbon is 12.01 per mole. You want to set it this way so the grams would cancel. And then simply divide 52.14 by 12.01. You should get 4.34 moles of carbon. Let's do the same thing in hydrogen. 13.13 grams times 1 mole. Divided by the molar mass of hydrogen, which is 1.008 grams. So, this will give us 13.026 moles of hydrogen. Lastly, we have oxygen. The molar mass of oxygen is 16 grams per 1 mole. So, 34.73 grams divided by 16 grams is 2.171 moles. The next step is to identify which number is the smallest among these three. Clearly, it's the moles of oxygen, which is 2.171. After identifying the smallest number, what we need to do is divide these three by the smallest value. So for oxygen, it's clearly 1. Next is hydrogen. 13.026 divided by 2.171 is equal to 6. And then for carbon, 4.34 divided by 2.171 is equal to 1.999, but we want to round it off to the nearest, so the answer is 2. Now, we have the subscript. So the empirical formula is C2H6O1. If the element has a subscript of 1, like the oxygen, we can just write it as C2H6O. Now, let's move on to part B. If the molar mass of the compound is 138.204 grams per mole, what is the molecular formula? So we have the empirical formula, now we need to find the molecular formula. The first thing we need to do is to find the molar mass of empirical formula. So there are 2 carbons, 6 hydrogens, and 1 oxygen. So it's 2 times 12.01 plus 6 times 1.008 plus 16. So the molar mass of C2H6O1 is 46.068. After getting the molar mass of the empirical formula, divide the molar mass of the compound, which is already given, by the molar mass of the empirical formula. So it's going to be 138.204 divided by 46.068. We're going to get 3. So now, to get the molecular formula, we need to multiply the subscript of empirical formula by 3. So this is going to give us C6H18O3. And that's how you find the molecular formula. Basically, just divide the molar mass of molecular formula by the molar mass of empirical formula, and whatever number you get, multiply the subscript of empirical formula by that number, and that is going to give you the molecular formula. And that's all for our class. Thank you for listening.